X-rays. What do we know about them? We know that they are a part of the electromagnetic spectrum. In fact, we know that they are rays whose energy is higher than the ultraviolet radiation, and they have a wavelength range of about 10 picometers to 10,000 picometers. Now, if you're wondering why we've dedicated an entire chapter to this small region of the electromagnetic spectrum, it's because they can do certain things that other rays simply can't. So the most common application of X-rays is its use in medical radiographs. In fact, I'm quite sure you would have taken one at some point in your life. But did you know it had other extremely interesting applications as well? For example, the double helix structure of the DNA molecule was discovered through X-ray diffraction. And also, we actually get to study stars and galaxies that are millions of light years away from us through the X-rays that they emit. So the discovery of X-rays affected our world in multiple ways. And funnily, it was discovered by accident. So how were they discovered? It happened long back in 1895 in a small town called Würzburg in Germany. So the scientist Röntgen was playing with the Crookes tube. A Crookes tube is basically a cathode ray tube. It consists of a chamber from which the air has been pumped out using a vacuum pump, and it consists of a cathode and an anode, and that is connected to an external power supply. He wanted to see how the radiation that's coming from the Crookes tube is affected by light that's incident on it from outside. So what he did was he covered this Crookes tube with a completely black opaque box, and then also turned off all the lights in the room to prevent any light from interacting with this Crookes tube. So when he did this, he found that there was a glow somewhere in the room. So when he investigated it, he found that this glow was coming from a barium platinocyanide photographic plate that was placed there by accident, that was just there coincidentally. He also found that when the Crookes tube was turned off, the glow ceased, and when the Crookes tube was turned back on, the glow was back again. So he was sure that the glow was coming because of some sort of radiation from the Crookes tube. And also, this meant that this radiation was actually passing through the opaque black box. Correct? This also meant that this was nothing like visible light, because this radiation did not help him see anything else. It only affected the photographic plate. Next, he tried other things. So he found that when he kept a piece of paper in the path of this radiation, there was no shadow on the photographic plate, which basically meant that this radiation was passing through this paper very easily. When he kept something heavier, or something a little more dense, like a metallic key, in the path of this radiation, he found that there was a shadow on the plate, which basically meant that this radiation, which could easily pass through the opaque black box and the thin piece of paper, could not pass through metallic keys or something dense. So it was stopped by dense objects. He also observed that when he placed his hand in the path of the radiation, just in front of the photographic plate, he could only see the shadow of his bones. This again basically meant that this radiation was passing through or penetrating the soft tissue of his hand, but was blocked by the hard bones, which basically cast a shadow. This obviously freaked him out a little bit, but then later he realized the applications. So he got excited and he called his wife. He showed her what he discovered and took what is probably the first X-ray radiograph ever taken, a radiograph of his wife's hand. So Röntgen named this mysterious radiation X-rays, simply because he didn't know what they were.